And welcome everybody to our webinar today. The topic is cost-effective EV charging with the Fronius Wattpilot. I will show you today how you can save electricity costs when using our EV charger, our Fronius Wattpilot. We are two in this for you today in the team. Beside me is also Anthony Moises. He will answer your questions during these presentations. Feel free to send them during the presentation, and we will answer them afterwards all together. My name is Hans Pelzer. I will guide you through the presentation, which will take about 15-20 minutes, and then we have another 10 minutes time for your questions. What topics do we have today? It's basically about some general considerations, how to combine a PV system and an EV charger, and what's best to get the best result out of it, how it works with the Fronius Wattpilot. So we show you how you can install it. Basically, main commissioning part as well. We'll show you then economic calculation with our creator tool, and also 2 reference projects where we have already installed the system. Finally, a short summary as well. So let's talk about some general considerations. So what is important first to know, or what to think about it? First, of course, how to use PV power from your PV system and for the EV charging, and how to reduce the electricity cost. Basically, you know, many countries, or most of the countries, you have quite low feed-in tariff and a high electricity tariff. So it's always appreciated to use the PV power to charge the EV. In most of the countries. Some countries have higher feed-in tariff, then it's not so important, but I'm talking today about those countries with low feed-in tariffs. Second, of course, the opportunities for charging are very important. Think about the customer itself. So it is of course different. A customer who is not at home during daytime can only charge the car at the evening, and then maybe to charge it on the weekend. If a customer is never at home during daytime, of course, it is very different to the one who has probably a home office and can charge the car always during daytime. So this has to be, of course, considered. Finally, we also want to have a safe charging because we want, there is also, of course, weeks where you have no sunlight or no PV production. And of course, also on these days, you need to have your safe charging. So this has to be also taken into consideration. And we want also to avoid grid connection overload, because that's also very, it's not nice to have the fuse tripping, and then, of course, the car is also not charged. So therefore, also that needs to be taken into consideration. And finally, we need compatible components. The components have to talk to each other, so there has to be communication from the inverter to the feeding point, and also to the Wattpilot or to the EV charger. Otherwise, it will not work. So how or why do we do the PV surplus charging? You can see here a picture of a PV production, a sunny day in summertime, a smaller PV system, but the customer is arriving at 4 p.m. in the afternoon, and he will charge his car with 11 kilowatt. So therefore, you see, maybe we have a 4 kilowatt production at this moment. So most of the power is coming from the grid, because he's charging with quite high power for a short moment, and then the car is charged again. But he has quite high electricity costs with that. When the electricity price is about 30 euro cents, for example, he will pay 2.30 euros for this charging of about 60 kilometer driving distance. So small autarky, not good. That's without surplus control. That's a standard use case of many of most of the people who have no connection to the PV inverter. When you have the Fronius Wattpilot, you can use the PV surplus charging. The PV surplus charging gives you the advantage that you can charge according your PV surplus energy. So you will see here in violet color exactly how the charging power is coming from your PV system. And we will only charge with that power which is available. So very high autarky, higher than 90%, and the electricity cost on that day is only 33 euro cents. So very low energy cost. Basically, you can say when you have very low energy feed-in tariffs and quite high electricity price, around 30 euro cents is quite common in many European countries. The PV surplus charging gives you only 1 euro cost for 100 kilometer driving distance. And for grid power use, you have 4.50 euro per 100 kilometers. So you see quite high price difference if you use your PV surplus energy or if you have your grid power to be used. And that's of course depending on the energy price, that's clear. I hope it's not very different in your country, but of course you can also calculate that and also see here the difference with other tariffs. So how does it work? Basically, what we need is a Fronius inverter. In this case, it's a Gen 24 Plus inverter or Gen 24 inverter, the Fronius Wattpilot, and a Fronius smart meter at the feeding point. It can be any Fronius smart meter, it can be any Fronius inverter. Maybe it has to be a communication, internet communication, that's clear, and the smart meter connection. And then you need the Fronius Wattpilot. What is the Fronius Wattpilot doing? He's communicating via LAN or Wi-Fi to the network, as well the inverter is connected to the network. And the inverter has the information from the smart meter at the feeding point, what energy is available at the moment. For example, in this case, we have 8 kilowatt energy which goes to the grid. And then the Wattpilot would use this 8 kilowatt to charge the EV exactly with that power. And that will be calculated all the time, of course. And when you have energy consumption, other consumption, it will be reduced and so on. Also, we can have with the Fronius Wattpilot the feature of the dynamic load balancing feature. So you can also avoid fuse tripping with that because you can set a certain maximum current on the Wattpilot, on the feeding point and on the supply line, which should not be exceeded. Otherwise, you could have a fuse tripping. The required components are the Fronius inverter, the Fronius smart meter, and the Fronius Wattpilot, and basically, of course, the communication. So communication via cable or LAN cable or via Wi-Fi. That's it. That's all. And of course, then you need to do some settings on the Wattpilot to make it work. What Wattpilot are available from Fronius? We have the Wattpilot Go and Home version 11 and 22 kilowatt. So this is the mobile solution. This is already existing for many years. So we have the product already since many years on the market. The Flex Home is the quite new one from last year, which also comes in 11 and 22 kilowatt. This is the stationary solution, which can be fixed on the wall, and you do the wiring on the wall. And the new one, the Wattpilot Flex Pro, this is the professional version for basically more commercial sites for companies which also need to have a certificate calibrated counter integrated in the Wattpilot. So this comes with this MID counter included. Whatever you need for the residential or for the commercial, up to you to use, of course, all also in the other installations. They're all compatible. They all use the same the commissioning app, the Solar Wattpilot app for the commissioning as well as for the use of the customer. Now we have two modes which are important. When you would like to use PV surplus energy and when you would like to charge your car on the cheapest as possible, the eco mode is of course very important to be selected. We have three modes: the standard mode, which car will always charge with the maximum power. The eco mode is the mode where we charge according to PV surplus energy. So this is very good when the customer is at home during daytime and you have a sunny day. You can see you can use the whole power, the whole surplus energy with your car. So all the violet part is then be charged into the car. Also, second, we have the opportunity with flexible energy tariffs that you use, that you set a certain electricity price value, so threshold. When you exceed that, or when you are below this, you can also charge your car maybe on a not so sunny day when the electricity price is very low. So also that's possible. It's a combination of PV surplus and very low electricity prices. The other mode is the next trip mode. The next trip mode gives you the advantage that you can define an amount of energy which you charge every day for sure, so that you have your safety that your car is really charged. Because with the eco mode, it could happen you have no sun, you have no low price electricity price, then the car will not be charged. With the next trip mode, you can guarantee a certain amount, which is defined, to charge the car during daytime first priority. As you can see here, as of 4:30, the car will be charged. And then again, at night, when the energy price is very low or low, it will repeat it to be charged, and you have your driving distance be charged. So basically, that's good for customers who are going every day to work. They know the driving distance every day, and they can set this driving distance, and you have your safe charging. So a tariff which cannot be used in winter time, but also in summertime, of course, and you have your safe charging. What settings need to be done on the next trip or eco mode? You have on the Wattpilot app the eco mode, or you can also, of course, have here the next trip mode or the standard charging mode. Below you can see the settings. When you click on the settings, you have some additional possibilities. On the next trip mode, you can set your driving distance per day and the time when the charging should be ready. So basically, for in this example, maybe 100 kilometers until 6 o'clock a.m. in the morning, then the car will be charged with PV power during daytime, and again anywhere at night when there was no sun at this day. So that's a very simple way. You just ask your customer about the driving distance, and that's it. Second part, which also should be adjusted, is the cost optimization. On the cost optimization, you can set a flexible tariff when the customer has a flexible energy tariffs, and you can also set the electricity price threshold. So the threshold, when you're below this, you can charge then your car also on the eco mode as well on the next trip mode. Additionally, you can set here also, you can see here which inverter is connected to the system. So you see the serial number then of the inverter, the Fronius inverter, which is connected to the system. So watch here if you have the connection to the inverter, to the right inverter possibly, that the eco charging or next trip charging is really using the surplus energy of your system. Both systems have to be online, of course, clear the inverter and the Wattpilot, and the smart meter has to be connected to the inverter. So that's it basically. With that settings, you have the best output. Now, what is about the battery storage? Is a battery storage important or not, or for which customer is it important? Basically, first of all, battery is always important for customers who are not able to charge their car during daytime, because then they can charge it in the evening with your battery power. Second, of course, it is quite important that the customer driving distance per day is not too high. If he's driving 200, 300 kilometers every day, then of course the battery needs to be very big. And of course, this is maybe not the cheapest way to do it. So the savings will also be not very good because the investment is so high for the battery. Our recommendation is around 100 kilometer is around kind of maximum, because for that you need about 18 kilowatt hour battery size. So with a let's say 20-25 kilowatt hour battery size, because you need also some battery for the household, you would need then a quite big battery, which is usually not for every customer the best solution. So below 100 kilometer, if it's a 10 kilowatt, 60 kilometer this driving distance, you have 10 kilowatt hour battery size additionally to your standard size, and then you can have a 16 kilowatt hour battery or Fronius Reserva, for example, which is enough for the customer to make it working. And it's still, the costs are not too expensive. Third point is, of course, the high price difference between feed-in tariff and consumption tariff. If you have high feed-in tariff, it makes no sense, of course. If you have a low feed-in tariff, it makes sense, and especially then also when the consumption tariff is quite high, because then the battery will pay off quite soon. So basically, a combination with a battery is recommended, especially for some customers who are not able to charge during daytime. Now, let's talk about economics now. We have a calculation tool, our creator tool, where we can do some calculations. And I have here 3 examples calculated. So this is a bit a theoretical calculation, but gives quite good view what can be achieved. So we have used a driving distance for a customer of 50 kilometers per day, so quite low driving distance, charging during the week only on the evening, on the weekend 1 day where you can charge his car. So it can be a Saturday or Sunday where you can charge during daytime for a few hours. We have 3 calculations done. One, a 10 kilowatt PV system without Wattpilot, a 10 kilowatt system with the Wattpilot, and a 10 kilowatt with Wattpilot and battery storage. So what was the result? Without the Wattpilot, we got a self-sufficiency for the EV of only 13%. So most of the power, 87%, came from the grid. So the customer has only a very small advantage of that, of the 10 kilowatt PV system. If you use the Wattpilot without battery, you can increase that to 32%. So only, the reducing of the power according to PV is already helping here, and you have already quite higher self-sufficiency. But of course, best result was with the battery, a battery of 15.8 kilowatt hours. So our Fronius Reserva 15.8, which gives a self-sufficiency of 78%. So you see here quite high difference, because this customer can charge only in the evening during the week. So there is a small direct consumption and a quite high battery consumption. And with the 50 kilometer driving distance, that's around 6 kilowatt hours per day, you can achieve this to be charged from your home battery storage quite easily. So this is of course only one example. You can do your calculations with the creator tool on your own. Just go to creator.fronius.com and you can try out, you can set the time when the customer is able to charge, and you can also set the driving distance per day, and you can do that from Monday to Sunday, and then you will get your result at the end of this calculation. So please feel free to use it. Yeah, so here we have the Wattpilot in these last two examples. So now, what's that in euros? With an energy price of 30 euro cents and a feed-in tariff of 5 euro cents, we have achieved for this customer, and he has an additional consumption of 6,600 kilowatt hours per year, so a total consumption with the EV of about 10,000 kilowatt hours. Then we have got a result, a savings in 10 years with the fixed charging, or let's say without Wattpilot, of 1,280 euros in 10 years. With the Eco Next Trip mode, so this this surplus control, you have 3,150 euro savings, and with the battery and the Eco Next Trip mode, you can have savings of 7,680 euros. Of course, this is also quite theoretical calculation, but basically we just assume that the customer is just plugging in the car when he's arriving in the evening, and he has set, for example, the next trip mode, where he gets his safe charging until the next morning. So all you need to do is plug in the car when you arrive, and of course plug out when you leave your house in the morning. And then you can achieve this with these electricity prices. You can do the calculation with the creator tool and you will get this result. Of course, you get the yearly result, and I've just calculated by 10 years without any increase of energy price. Just multiply it by 10, and then you have your 10 years savings. So you see, it is quite important to do it, to use the Eco Next Trip mode. It's quite important to control it from the PV inverter. And of course, battery is recommended, especially in this case as well, where the customer can charge only in the evening. So two reference projects, one quite small system, 6 kilowatt system, smaller driving distance of 12,000 kilometers per year, 8 kilowatt hour battery storage, and electricity consumption of 1,620 for the EV, with a 90% home charging. 10% is also external charging on the highway, fast charging sometimes needed. This gives an autarky from 57% and savings per year of 230 euro, or within 10 years of 2,300 euros, with this electricity price of 30 cents for the battery consumption, and 5 euro cents for the feed-in tariff. So this is a real result. So it is not, of course, not every year exactly the same amount, but it's roughly around this, from 200 to 250 euros per year. So this is a real part. The second is a bit higher driving distance of 15,000 kilometers with a bit bigger PV system and battery, 10 kilowatt peak, 12 kilowatt hour battery, autarky of 65%, and savings of 370 euros, or in 10 years of 3,700 euros. So of course, as higher the driving distance, as higher the benefit, as more often the use of day charging, as better. So that's also then the part a little bit from the customer behavior, to increase that or reduce that slightly. Basically, this amount of price savings can be easily achieved. It can be even better when the customer, for example, charges his car more often on the weekend and uses that more often. And this is a case of Austria. Of course, there are parts in the world where you have more sun, and of course also lower sun. That's also possible. So it's maybe anywhere in the middle, let's say, of the possibilities. Good. A short summary of that, what I've told you today. Basically, think about the energy cost savings with PV power. It's really, in many countries, there's a big difference between PV charging or grid charging. So €1 to 4.50, let's say. The charging behavior is, of course, important. Talk to the customer, try to connect your car every day when you come home. Select the next trip mode, for example, for safe charging, and try also to connect on the weekends, especially on the sunny days, because with that you have your most benefit. And of course, higher savings with the battery, that's also recommended, especially for some customers which have not possibility to charge during daytime. And of course, using compatible components is very much recommended. Try to get if you have a Fronius inverter, with the Fronius Wattpilot, we can easily communicate with the inverter, get your smart meter on the feeding point to know what's the surplus energy, and then you have your system ready for a good benefit of your system. So yes, that was my presentation. I will send you the recording tomorrow. You will receive that. You can watch that once again. More info on our webpage, www.fronius.com, and the calculation tool is ready to be used free of charge. Our online tool, creator.fronius.com. You can select the different PV system sizes, different behaviors of the customer, charging behaviors and cars, and then you get your calculated results. Can also watch, of course, our trainings, webinars, online trainings, and how-to videos where we show you exactly the commissioning process of the Wattpilot, for example, of the inverters. So just go to how-to Fronius 1024 or Wattpilot, and you will get the commissioning video, how to do the commissioning. Good. So that was it from my side, and I would now